Okay, so now they give us a graph and they want us to write the equation for the graph. And I'm assuming we're going to use y because they don't have it labeled f of x. Okay, let's do the easy part first. So think about, your old absolute value function. Looks like that. And where did that peak go? Kind of that 0, 0 point. It went 1, 2, 3 units to the right, so 3 right, and 2 down. Okay, so that tells us some stuff. The hard part is the stretch, right? Now you might be asking, well, how do I know if it's reflected? Well, it's not a mountain. If it were reflected, it'd be like upside down. That would be a reflection. And then you could still have the other things, but this one's not reflected, so we don't have to worry about that. But how are we going to know? Well, notice that when we had our original in orange here, it was 1 over 1 up, right, for the next point. Well, if I go 1 over and 1 up, it's not on the graph, so it must be a stretch. It's actually 1 over and 2 up, it looks like. So it looks like it's a stretch of 2. You could check another point, like you could say, okay, well, what happens if I go -1, -2, -1, -2, and I'm up here at 2. But now if it's a stretch of 2, I should be at 4, right? So if I go -1, -2, from this little bottom point, that little tip of the V, -1, -2, and I go up 1, 2, 3, 4. Yeah, I'm on the graph. So yeah, it looks like a stretch of 2. Okay, so now we just have to write this as an equation. Y equals, I'm going to put the stretch first, 2, absolute value, and then this 3 to the right is going to be x minus 3, and then 2 down, that's going to be minus 2. So this should represent an equation for the graph. And you can check it by checking some ordered pairs.